Welcome to the full end-to-end Solana blockchain and smart contract bootcamp. We're going to go through everything you need to know from a technical standpoint to get started building on the Solana blockchain and write your own full stack decentralized applications. Whether or not you have been in the cryptocurrency space for a while or are just getting started, we'll be taking you through your journey to learn how to become an expert Solana engineer. At the time of recording, Solana developers are in high demand. We're seeing a ton of jobs getting posted within the Solana ecosystem. Over the last 3 years, Solana developers participating in global hackathons have created companies that have received over $600 million in funding. And on average, blockchain developers right now are making more than $170,000 a year. While we cannot guarantee you a job, we're going to try our best to provide you with the skills you need to become a Solana developer. Whether or not you have any blockchain experience or have been building for a while, if you are interested in building in blockchain, this is the course for you. We'll be starting with blockchain basics, then going into full end-to-end projects, and finally finishing up with what it takes to get your new application to production. If you have already built some smart contracts or are familiar with blockchain, feel free to jump around the bootcamp to find which projects best fit your needs. You'll be able to find all the information you need to know about each project in the description, as well as in the GitHub repository linked below. You'll find the entire bootcamp in this GitHub repository, including any possible resources you may need, such as links to documentation or further reading on topics. Throughout this bootcamp, we'll be learning how to build on a blockchain and be using both Rust and TypeScript to accomplish this. Don't worry if you don't know these languages, as we'll be teaching you enough to get started throughout each lesson. As long as you have some software development background, you should do well. Even the best developers don't get it right the first time. If you do happen to run into issues at any point in this bootcamp, there's a Solana-specific Stack Exchange where you can get help. The Solana Foundation Developer Relations team and other developers from the ecosystem will be answering your questions there. Just make sure you search for your question first and provide enough information about your error you received while building each project. We will also post the full solution at the end of each step and in the notes below. It is incredibly important that you pace yourself while going through this bootcamp. This is a marathon, not a sprint. Take breaks so you can have some time to digest what you have just learned. Go back to different projects as a refresher. Take the course at your own pace. My name is Jacob Creech, and I'll be working with you on some of these projects throughout this bootcamp.
I'm Brianna Migliaccio, and I'll be leading you through how to build smart contracts and decentralized applications.
And I'm Mike McKenna. I'll be working with you throughout the bootcamp on key blockchain concepts. Before you start building, you should understand the purpose of blockchains and the problems that they solve. Fully understanding the value blockchain provides will help you leverage it to solve the right problems. So let's get started. So what is blockchain? Why is it important? And what can you do with it? At its core, a blockchain is a distributed database with some special characteristics. Unlike most databases, blockchains are unique in that they have no central authority, are fully open for anyone to use, and all data is completely transparent. Everyone can make payments on the blockchain, while no one entity is capable of stopping or reversing those payments. This is what we call censorship resistant. The transactions are irreversible, and the blockchain itself is a recording of those transactions. That's why blockchains are often referred to as a ledger. Unlike databases, which are typically stored in a central location, data on blockchains are stored on multiple computers across the world. Essentially, there's no single copy of the blockchain that can be lost or tampered with. Instead, the data is stored in multiple copies and verified by checking the blocks or bundles of transactions. This is called decentralization. What this means in practice is that blockchain allows people to transact with each other directly. Think about the last time you paid for something, or swapped currencies, or just stored your money somewhere. You might have used a credit card, or a money transfer service, or a bank. To facilitate that, there's typically a service fee involved. The seller pays a couple of % on every credit card transaction. You pay a little bit more for an international transfer. And your bank probably has a monthly fee just to hold your money. Blockchain allows people to transact with each other directly without needing somebody in between. Now, to understand blockchain, you need to start with Bitcoin. Back in 2008, Bitcoin was created by the pseudonym Satoshi Nakamoto as a way to make digital peer-to-peer payments. The white paper for Bitcoin outlined a way to make those payments without having a trusted third party, such as a bank or other financial institution. Blockchain uses digital signatures to let people transact without having to fully trust each other. Digital signatures give us confidence that the money sent is in the correct currency, that the amount is correct, and the amount was actually sent. Bitcoin was created more than 16 years ago, and these days it's less used for day-to-day transactions. People think of it more as digital gold. However, plenty of new innovations have been built since then. Modern blockchains, like the one that we'll be building on, Solana, support fast payments with lower fees than both Bitcoin and traditional finance. Not only that, but new creations, like smart contracts, have enabled a whole new set of capabilities previously not available to blockchains. Smart contracts are computer programs that run on a blockchain. Instead of having a cloud provider run your program, you run the program in the blockchain. Smart contracts are a little bit like APIs in the traditional tech world, except rather than being invoked by requests, they're invoked by instructions. And rather than sending responses back, they write their changes out to the blockchain, where anyone can read. Smart contracts extend blockchains beyond simple payments to allow complex transactions that could lend money without a bank, allow people to exchange items directly with each other at a price they both agree on, or even create a lottery without a lottery ticket issuer. We're going to build these in this bootcamp, so you can see how powerful smart contracts can be for yourself. Blockchain would not be possible without cryptography. Everyone that uses a blockchain has something called a key pair. A key pair consists of two keys, a private key and a public key. The public key is shown to anyone. It's used as an address people can use to transact with you. The private key you must keep secret. The private key is used to sign transactions, which proves that you made them. For example, want to spend some of your tokens. You'll need to sign the transaction using your private key. Anyone else can use your public key to verify that you, as the holder of the matching private key, made that transaction. Key pairs are pretty common in cryptography, even outside blockchain. Let's use the example of passports. Your electronic passport is signed by your government, using your government's private key. When you pass through the passport gates at the airport, they use your government's public key to prove your passport was really signed by your government. If the passport signature is correct, it must have been signed with your government's private key. If I make my own passport, it won't be signed by my government's private key, so I won't be able to get through the gates. In Solana, everyone has a public key they use as their address. Other people can use your address to transact with you. The most basic Solana wallet is just an address with a small balance of Sol. Users can pay their transaction fees and interact with smart contracts using Sol. Here's Alice's wallet. Here's Bob's wallet. If Alice wanted to send Bob some Sol, she would use her private key to sign a transaction that uses the system program's transfer function to send some Sol to Bob, and uses the memo program's memo function to write a little note to Bob about the transaction. If both these steps, called instructions, are completed successfully, the transaction completes successfully, and Bob receives the tokens in his address. If something goes wrong, that's okay. The transaction fails and nothing changes. Alice will still have her Sol. Blockchain technology allows for new applications to be built in this digital age. We can create systems where people transact with each other directly, make digital assets that can be sold or used outside of a game, allow art to be sold, and ensure artists get paid each time a piece of artwork is transferred. The projects we'll be building throughout this course will use the Solana blockchain to create unique applications that can only be built with smart contracts. Let's get started with your first application. The first smart contract we make will be simple. It's going to save our favorite things to the blockchain. We're going to learn how we can save, update, and retrieve information from the blockchain, and how signing is used to control access in our smart contract. In the previous lesson, we learned how everyone has a key pair, a public key that can be used as an address to transact with that person, and a private key that they use to sign transactions. In Solana, your smart contracts or programs can store additional data in what's called program-derived addresses. PDA addresses are not made from a public key. Instead, they're made from seeds, which can be whatever you, the programmer, want. Want to store some config for your smart contract? You can make a PDA from the seed config as a string. When you need to find your program config, look for the PDA made from that seed and you'll find your config. Want to store Alice's review of the movie Titanic? You can combine Alice's wallet address and the string Titanic to store the movie review. Need to store Bob's review of the same film? You can combine Bob's wallet address and the string Titanic to store his review. If you've used a key value store before, you might be thinking this is familiar. And yes, Solana PDAs are a type of key value store. If you haven't used a key value store before, you can think of a PDA as a row of data, with the seeds being the primary key used to find the data. So let's build a simple app that saves someone's favorite things to the blockchain and uses digital signatures to ensure only the wallet holder can update their own favorites. We'll use Solana Playground and Anchor, the most popular framework for making Solana programs. So we're going to be using a tool called Solana Playground, which lets us make Solana programs or smart contracts directly in our web browser without installing anything on our local machine. So open beta.solpg.io, click Create a New Project, give your project a name. I'm going to call this project Favorites because it's going to save our favorite things to the blockchain. And we'll pick the Anchor option and click Create. There's a file made for you, but let's actually delete everything inside that file, that librs file. We're going to make everything from scratch ourselves. So the first thing you'll see in pretty much any Anchor program is importing what's called the Anchor prelude, which is the thing you'll see at the top of almost any file and allows us to access everything from Anchor just by typing its name rather than typing out the full path to it. So use Anchor lang prelude star. That pulls in all of our prelude into the current scope. The double colon is just Rust's separator for namespaces. Other languages would use a dot for the same thing. A program has a program ID, also called an address. I'm going to set up a program address for our smart contract. In Solana Playground, we don't actually need to fill this in. It will be done for us when we deploy our program. Also, just for neatness, I'm going to make a little constant here. And I'm going to call it Anchor discriminator size. The Anchor discriminator is something that's written to every account on the blockchain by an Anchor program that just specifies the type of account it is. And that's used by Anchor for some of its checks. So that is a use size and the value is just 8. So when we save things to the blockchain, we'll need 8 bytes plus the size of whatever we're saving. You'll see that later on. Now, the great thing about Anchor is that we can take a regular Rust program and with a particular macro, turn it into an Anchor program. So here is just a regular Rust module, pub mod favorites. And it's going to use all those good things we just imported a moment ago. And it has a function. So pub function set favorites, which is going to return nothing. Return nothing. And here is its body. So this is just a regular Rust module. It's called favorites. It has some functions inside. In this case, just one function, set favorites. But the great thing about Anchor is that if we do this macro program, suddenly that favorites Rust module becomes a full Solana program or smart contract. This is the power of Anchor. It saves you from having to do boring things and also applies a bunch of sensible safe defaults. So set favorites, that function, is now a Solana instruction handler. It will take instructions that are provided by clients and run them and then save the results to the blockchain. So let's think about what we're actually going to save to the blockchain. We're going to save people's favorite things. So that's going to be a struct called favorites. And inside, we're going to save people's favorite number, which will be a 64-bit or 8-byte number. And we will have a favorite color, which will just be a string, and we'll have a list of hobbies, which will be a vector of strings. So pub hobbies vector, it's a little bit like an array of strings. Now, because we're going to save this to an account, we will also put the account macro on it.
And to let Anchor know how big favorites is, we're also going to put this derive init space. That gives us all of our instances of favorites the init space attribute, which is the total space used by all the items inside. We'll also need to specify the size of each individual item to get that. Obviously, strings could be any size at all, so we'll need to specify a max length. That's max len, say 50 bytes, and I'll copy that for hobbies. Hobbies is nested because we have a vector of a certain amount of items and then strings which have a certain size. So for hobbies, we'll say 5 and 50 for the vector and the string, respectively. When people call our set favorites function, they're going to need to provide a list of accounts that they're going to modify on the blockchain. One of the things that makes Solana great is that if there's a bunch of people over here who are running a transaction involving their accounts, and there's a bunch of other people over here running a different transaction involving their accounts, those transactions don't block each other. There's no overlap in the accounts evolved. So Solana can process them at the same time without waiting for the other one to be finished. So we'll make a struct to store this information, and we need to come up with a good name for it. Now, this is the struct of accounts for our set favorites instruction handler. So the tradition is to call this struct of accounts the same thing as our set favorites instruction handler, just in title case. Structs in Rust have title case, and the convention is to name the struct the same thing as the function itself, just in title case. We could call this set favorites accounts, but it's good to get along with other people, and this is the convention. So pub user, we're going to need people to supply an account that we call the user, and that's going to need to be a signer. You'll see me doing this info stuff here. All that is saying these items will live for the lifetime of a Solana account info object. This is just Rust having rules about how long things should be kept in memory. This isn't a Rust course, so I'm not going to go into lifetimes fully, but we'll throw some links in the course description so you can learn a little bit more about lifetimes if you want to. So we're going to specify some options for this account. I'm going to say that the signer is mutable. Why? Because the person that signs the instruction to set favorites is going to pay to create their favorites account on the blockchain. You're going to pay to store that information. Also, we'll need the person running set favorites to specify the favorites account that they want to write to. It doesn't mean that we'll let them write to this account. We just need them to specify the account. So we'll call that pub favorites. And the type is it's an account that goes for the lifetime of info, and it is an account, which is an account of this favorites struct that we made earlier. We're going to add a few Anchor account options as well to favorites. The first thing we're going to do is specify init if needed. Init if needed says make the favorites account if it doesn't already exist. We'll specify who pays to create the account, which, as we said before, will be the user, this person here. And that means the user is the person who signed the transaction. So the person who signed the transaction will be the person who pays to create the favorites account. We're going to tell Solana how much space this account needs. So every account in Anchor has 8 bytes, or the Anchor discriminator size, using that constant we made earlier, plus whatever the size for this struct. So when we made our favorite struct, which specified what favorites look like, their types and the different keys that we need, we said derive init space. That gave us this great init space trait, which we are using to calculate the size we will need for a favorites account. In other words, a favorites account is just an account that has an Anchor discriminator and stores favorites. We'll need to have some seeds. Now, the seeds are what's used to give this account an address on the blockchain. This is a program-derived address. Unlike regular user accounts, this isn't a public key. The address for this is actually made based on some seeds that we provide. So if ever you've used a key value store, this is a really similar concept. The keys, in this case, are whatever we have as our seeds. And I'm going to use, in this case, the text favorites as bytes and just the user's own key as well. This means that if I'm storing my favorites, I will store that under the address made from favorites as bytes and my own public key. And if I'm storing your favorites, I will store that under an address made from favorites as bytes and your public key. So what we're doing here is storing information under different accounts that are found based on the inputs we give, and the inputs we give are based on the users. Finally, we'll also specify the bump, which is just used to calculate those seeds. We have pub favorites, and it's an account of type favorites. That looks good. The last thing we'll need to, the last account we'll need people to specify is just the system program. The system program is used for so many things in Solana. If it's not the system program, it's the token program. So that will be a program. It lasts for the lifetime of info, and it is a program of type system. That looks good. So at this point, we have our favorites struct, which is what we're going to write into the blockchain for every user. And we have our set favorites list of accounts that people need to provide, which is also a struct. Let's go and fill in our set favorites function, which is our actual instruction handler, the thing that people are going to call from the instructions in their Solana transactions. We can do, let's do a little greeting message. Solana has this message macro that's built into it, or Anchor actually has this message macro that's built into it. We can do things like greetings from, and we can say context .pro. So message is kind of like console log or print line. It just writes things out to the Solana log file. If you use Solana Explorer, you'll actually be able to see these messages when someone has a transaction that makes a call to this instruction handler. Let's also make a little variable just to show the user's public key, the person who's calling our instruction handler. User public key equals context.accounts.user.key. That's good. Let's add another log message that just logs out the options that people have provided. User Now I just realized that we needed to provide some arguments to set favorites, and we haven't done that yet. So let's do that now. Context. The first argument to our set favorites instruction handler will be a context, which is a context of set favorites. In other words, the set favorites accounts that we made earlier. And I will spell favorites using American English. So I'm consistent. We'll also ask people for all the options they want to save. So that's the number, that U64, their color, which is a string, and hobbies, which is a vector of strings. Save and let Solana Playground do its formatting, and that looks good. So yeah, our set favorites has a context, a number, a color, and hobbies. And you can see that we can access information about like what program we're part of or all the accounts that people have specified through that context parameter. So back to our message, we have user public key, and we're going to log that their favorite color is, or their favorite number favorite color is color, and their hobbies are hobbies. And just because hobbies is a vector of strings, we're going to add a colon and a question mark so it expands the items inside that vector of strings. The last thing we need to do inside our setFavorites function is go and actually write the information into the favorites account provided. So that is context.accounts.favorites. And if we do a set inner, we can write information into that account. And the information we write will be an instance of the favorites struct with the number, the color, and the hobbies that have been provided. That looks good. Finally, we will return just with OK and nothing, that empty brackets. And we don't need a semicolon on that last line. We omit the semicolon and Rust returns the actual OK response. This is how Solana instruction handlers work. They write information to the blockchain rather than returning it. So that's our completed anchor program. We import the prelude. We set up the ID or program address. I like to make an anchor discriminator size rather than adding 8 later on, because we know that's how much space that every anchor account needs at minimum. We have a Rust module that has functions inside, and we apply this Solana program macro that turns that Rust module into an anchor program. And then inside that module, each function becomes an anchor instruction handler. Each instruction handler has a context, which is all the accounts that the people calling that instruction have provided, plus any other arguments for the instruction. We're going to log a couple of things, and then we're going to save the information somebody has provided to the favorites account. We return OK, just to let calling programs know that this instruction was completed successfully. If all the instructions in a transaction complete, then the transaction is considered complete and everything is written out to the blockchain. If anything fails, then nothing changes. And we have 2 structs. We have our favorite struct, which defines what we want to write out to the blockchain. In this case, a number, a color, and hobbies. And also we're going to add this great init space macro so we can easily calculate how much space it will take to store that. And finally, we have our accounts struct, which I actually realized we need to add derive accounts to the top of, so that Anchor knows this is our account struct. And that specifies the accounts that people need to provide along with the instruction. So in this case, it's just the user, the favorites account, and the system program. One of the things that is great about this program is that it already ensures that the person that is signing the program has to be writing to their own favorites account. And we'll test this in a sec, but I want to show you the logic here. In our account struct, we say we have an account called the user, who is whoever signed the transaction. And in our favorites, we say that favorites accounts, the seeds that are used to find its address, are made from favorites and that user's key. So if Alice signs this transaction and tries to write to Bob's account, it won't actually work because the address of the favorites account won't actually match her user account. We'll see this in a second, but it's a good example of one of the things that Anchor provides for us out of the box in terms of smart, safe defaults. Cool, so that looks good. I am going to build this program, so I'm going to slide this little doohickey at the bottom up. So let's click the build button and build our program. We might have some errors, we'll find out. Yep, and we do. It looks like I made a typo because I'm not very good at talking and typing at the same time. I meant to return a result. Instead, I wrote the word return. So let's go and fix that. That returns a result. of nothing. There we go. And let's build again. There's another error. Let's go have a look at the first one. I can see that's really obvious. It says on line 44, we have derive accounts, and that should actually be a capital. So if we build once more, you can see the syntax highlighting actually makes that look a little bit better as well for the accounts. You can see that completes successfully. That's great. Now we will need to deploy. When we go and deploy, Anchor will actually go and make a key pair for us. We can save this if we want to. I'm not going to use this again, so I'm not going to, but maybe you should save the key pair. And it says we don't have enough SOL to complete the deployment. I'm not going to request an airdrop. Instead, I am actually going to use the Solana faucet, which has some more features to get airdrops than the inbuilt Solana Playground airdrop tool. An airdrop, by the way, is just a way of getting free DevNet SOL. So if I open up that address, you can in Solana Explorer, you can see that it has no balance. It's a balance of SOL is accounted does not exist. Data size is 0, etc. So if I go and copy that address and then go to faucet.solana.com, paste in my wallet address, and let's ask for 5 SOL. Why not? And you'll see the message airdrop was successful. If I go back into Solana Explorer, you will see that I now have 5 SOL. Excellent. Great. So let's go and I'll clear those old log messages, and let's hit deploy again back in Solana Playground. Good. So it's deploying, and it says it can take a while, which it does. And you'll notice while it deploys, it actually takes a little bit of my SOL to do that deployment. And it's finished successfully. So let's go check this out on Solana Explorer. There's actually a transaction for deploying my program. And you can see that transaction was successful. My deployment was successful. Good things. Excellent. So back here, we have our Solana program, and it's been deployed on Solana DevNet at the address. You'll see, by the way, that Solana Playground actually added our program's deployed address inside declare ID, and in Solana Playground, we can actually go and search for that address and find our program there. It has some executable data. It's upgradable. There's the upgrade authority, which is the temporary key that Solana Playground made for us. In my case, it starts with F. Great. Solana Playground also has a test tab. It's this little test tube on the left. And this allows us to actually invoke any of our instruction handlers on the blockchain straight from Solana Playground. So in this case, I can go and set the favorites for the temporary wallet that Solana Playground made for me. I'm going to specify my favorite number, which is 7. Click custom. Color, which is red, custom. And hobbies, which is skiing and bike riding. That looks good. Custom. So as well as our favorite things, people calling this instruction handler will also need to specify the accounts that they want to use. So for the user, pick the current wallet. For the favorites, pick from seed. And the first seed will be what we had before, which is the string of the word favorites. There we go. Oops, sorry, I need to hit that string custom favorites. There we go. I'll add a seed, which is just the current wallet. And that matches what we had before, where we're calculating the seeds to find this favorites account from those inputs, the word favorites and the current user's wallet. Now, our program actually checks that the favorites account we write to belongs to the signer. And I'll show you what happens if someone else tries to write there later on. The program is already written for us. It's just the public key of our actual program. And I think that's it. So we can go, let's make that seed. Click that generate button. And if we hit the test button, we've actually made a transaction to our program. So let's open that up on Solana Explorer. So in Solana Playground, here is our transaction. And it had only one instruction, which is the call to our set favorites. And if you look in the logs here, you can actually see some really interesting things. And I'll make this font a little bit bigger as well so you can see that. It says, greetings from our program's public key, our user, our wallet address, their favorite number is 7, their favorite color is red, and their hobbies are skiing and bike riding. And you can see that that's actually saved that out to that account. The way you can do that, by the way, is you click on favorites. And if you just do fetch all, you can actually see that in Solana Explorer, we have for the public key of our user, we have a number, a color, and a set of hobbies. Now, what happens if another user tries to write to our favorites? So back here, if I pick for user, if I get rid of that and I replace current wallet with random, but I'm going to leave in the favorites account that was made from the previous user. So if I test that now, if I try and run a transaction where I'm writing to someone else's favorites account from a random wallet, you will see that a seeds constraint was violated and the instruction did not complete successfully. This is one of the great things about Anchor, is that these controls over what accounts people are allowed to write to are, really handled for us. Most of it was, this logic that we set up inside the set favorites account struct, where we said that the user is whoever signs the transaction, and the favorites account must be made from these seeds. If they specified a different favorites account that was not made from those seeds, that's why we get a seeds constraint was violated. So you've now made a program, deployed it to Solana DevNet, and seen how Anchor's account constraints allow us to control access to data on the blockchain. You've also, by the way, written data to the blockchain and read it back. In the next steps, we're going to install Solana on your own machine and create more programs that do more useful things. See you soon.
The next application we're going to build is all about voting. Traditionally, democratic governments hold elections and collect votes from the population. There's a multitude of ways that people can vote, but verification is still a very human process. Votes are added to a ledger, and after a long period of time, the results will be released. Using blockchain technology, we'll not only be able to immediately calculate the votes, but we'll also be able to instantly verify a user voting using key pairs. In this project, you'll learn how to manage accounts and build using program-derived addresses with best practices. Let's get started. Hello, my name is Jacob Creech, and we're going to be building the voting application. Before we get started on that, we have to build up our local environment to actually build our voting application. This is contrary to the previous application that you built, the Favorites app. We're going to build it locally versus all within the Solana Playground. So let's get started on how you set up your local environment. All right, so first thing that you need to do is you'll need to install Rust. And the web page that I'm looking at right here is the Anchor docs for installation, and it has a full list of all the different things you need to install. So first thing we're going to do is install Rust. We go to this website, and we just use this command. So let's go type it into our command prompt and let it run. So this will just make sure everything is set up on our computer to use Rust to compile Anchor and other Solana smart contracts. All right, so this is going to update my Rust home variable. It's just giving me all the information to do the installation. And so I want to just proceed with standard installation. And here we go. All right, so now we've had Rust installed, and the next thing we do, as it says, is we have to make sure that we reload the path variable. So we can see that here we need to make sure that To configure current shell, you need to source the corresponding environment variable under home cargo. It's usually done by cargo environment or cargo environment fish, depending on what you're using. You'll have to know exactly what your current installation is or whatever type of computer you're using, but this should give you the right information to do the correct thing. So let's go make sure that we have Rust up. I believe it's just Rust up. Yep. So we typed in Rust up, and we can do Rust up -- version, and it'll tell us that I installed Rust up 1.27.1. We're all good to go, and we can see my active Rust version is 1.79.0. So that is everything that you can see. They're like, oh, I have properly installed Rust on my computer. And the next step that we need to do is we need to install the actual Solana toolchain. This is so that we can do a bunch of different Solana-related things like creating key pairs locally or compiling our smart contracts and more. So we click here, and it'll take us to the page to do the installation. So we can see here that there is a CLI command to install. We just copy and paste it into our terminal. So let me paste it right here. And this will pull down the Solana binary in order to run the Solana toolchain locally. All right, so now we see that it was installed. We've installed Solana version 1.18.18, and it's telling us to do an export onto the path. So we can just run this thing right here, and it will export our binary using Solana onto our path variable. This just basically allows us to use the Solana CLI. So then we can open a new terminal. Let me make it bigger for you all. And we can type in Solana -- version, and it should give us the version number. And see here we have Solana CLI 1.18.18 installed. So we're good to go. We can also check in this other terminal just to make sure that we did everything correctly on the Rust. Version. There we go. And we have 1.27.1. So let's clear this and close out of this terminal. All right, so we're back to here, and we keep following the docs pages. The next thing that it has us do is we're installing Yarn. You can also install npm, you can install pnpm, you can use bun. You can do whatever flavor of package manager you use for JavaScript, doesn't matter. This one says install Yarn. I'm not going to show this because it's like there's pretty good documentation out there because it's outside of our ecosystem. So go ahead and install your favorite package manager for using Node.js or something, or JavaScript. The next thing we need to do is we need to use the Anchor version manager. This is so that we can have the correct version of the Anchor framework locally in order to compile smart contracts on Solana. So this just tells us to do cargo install. So let's go ahead and do that. All right, and that's Anchor installed. So you can see that it installed 0.30.1, and we can go open a new terminal and see if it actually worked correctly. So let's make this bigger for y'all. avm -- version, and we can see 0.30.1. And in order to set your current Anchor version locally, because this is just the version manager, you do Anchor or avm use, we're going to use 0.30.1 throughout this bootcamp. And now we're using 0.30.1. So that should have everything that you need to get started, I believe. Let's just double check with the docs. All right, so this has some more information to make sure that you have everything right. It also tells you to do Anchor -- version to make sure we're using 0.30.1. And so we have Anchor CLI 0.30.1. So now the next step is what we're going to do is we're going to set up our project for creating the voting app. I'm going to just make sure I'm in a good directory that I like. I'm going to make a temporary directory for us. There we go. Let's make sure. Bootcamp temporary. All right, so here what I'm going to do is I'm going to do let's make sure it's bigger. All right, so here what I'm going to do is I'm going to do npx create -solana -dapp, and you just type in that and hit enter. And what this does is it will create a scaffold for building all your different projects locally on Solana. So here we first got to enter our project name. We're doing a voting dapp. We're going to use Next.js for this. We're going to use Tailwind. We might as well have the counter program. That's fine. And it'll start creating the workspace. And so once this finishes, we'll have a template or a scaffold in order to start building our voting app locally. This makes things a lot faster locally as well. All right, so we've created our template Solana project, and we can actually start running it. So if you go, we can do ls here, and we can see that there's a voting dapp folder now. We'll go cd into it. And if we do an npmi, I used npm locally, that's fine. So we can install the npm modules to get our web front end running, and then we'll do a npm run dev to run our actual website. So npm run dev, and it will open on localhost 3000. So let's go look at localhost 3000, see what presented us. All right, so this is basically a placeholder or a scaffold for us to create our application. This is what we're going to use completely to build out our voting application within Solana. We have everything here. There's a bunch of placeholder stuff that we'll remove later on. We're going to focus on the program side first, or the smart contract side, and build that out. All right, so let's go look at our other local stuff. So going back to here, we're going to open another new terminal. So another thing part of local is that instead of running things on DevNet or an environment that's not on your local computer, we're actually going to run a validator locally that has a lot of the same capabilities that you would see in a validator on the actual live network. And we can just simply do this with the Solana toolchain by running Solana test validator. So you want to run this locally also to test and make sure everything installed correctly. Just as a note, if you're using Windows, you will want to have this all installed on WSL. Otherwise, it might not work. And what you can see here, the JSON validator is running on port 8899, and it's processing slots. You can see it's at slot, what is this, 1,300,000, and the confirmed slot is moving forward, and we're all good to go. And it's running. And so actually, if I run this and I click here and click on local, you can do things on local. So you can probably, let's say we can see in accounts. I can see that I have an account with this much SOL on local, no token accounts and everything. This is the majority of your time is going to be spent using the local validator to build Solana smart contracts. Another thing is locally, you can use the Explorer to look at everything that's happening on your local validator. You don't have to go do some API calls or something to figure out what's happening. You can all do it via the UI on the website. And how you do that is you can go to explorer.solana.com, you click here, click custom RPC URL, and that should be set by default to your current local host, your current local validator. So we can just click that, and boom, we have that. We can see a bunch of live stats. So 1,300,915,916. We can see that roughly matches up. This will be basically off of the finalized slot. They're equal from the front end to the back end. And using this Explorer, you can see a lot of the different things that you're doing locally and making sure that you're validating your transactions. You're making sure that the instructions that you're setting are correct. This is the full local setup so that you can actually run all of your code locally, iterate a lot faster, and not have to worry about other environments. It's very important that everybody, and this is what we're going to be doing throughout the whole bootcamp, is everybody uses the local test validator and gets very familiar with how to use it correctly. All right, so we have it running. We have our developer environment running. We have the voting dapp running here on a website. We can see I'm connected to it. We're all good to go. Everything is ready for us to get started on local. This is all the setup that you needed to start building local development on Solana. What I like to do is before we build anything on the voting dapp, I want to make sure that we understand exactly what we're going to build. We're going to architect all the different things that we're going to build before we actually write the code. This is so that we kind of understand what we're thinking when we build out the application so that we don't have to keep rewriting the same code over and over and again. So I'm going to draw it up here, and we're going to give the full architecture. All right, so this is basically a whiteboard. I'm going to use this to draw out the voting DApp. We're going to create a voting application that's going to do two things. We're going to either be able to vote for an account. We're going to vote for crunchy or smooth peanut butter, basically. So if anybody wants to vote for their favorite peanut butter, say you enjoy crunchy better than smooth, vote for that one. And then if you want to do smooth versus crunchy, vote for that one. It's a very easy way to showcase. But you can kind of see like how this extends to real-life applications, say like an actual election or your school representative election or something. You can actually decentralize this to where every single person has a public and private key, like you learned early in this boot camp, and that is their identifier. And you know that they voted, and you can immediately count the votes that they have for a specific candidate online. So let's draw this up. Okay, so part of this diagram or this architecture is we have to understand what accounts that we need for our smart contract before we write it. So here we'll be creating basically polls, right? So we're going to have a poll account. We know that. And then we're going to need candidates. So we're going to create another candidate account. We're going to have, I think what we're going to do is for each candidate, we'll have an individual candidate account. So there could be multiple of these. So let's just create a bunch of them so that it's easy to remember. And these candidates will have some information. So each of these accounts, since these are both different types of accounts, will have different information about what is the poll and what is the candidate. So the candidate, that makes sense to have candidate name as who you're voting for, and then maybe there is a candidate vote amount. This is so that you can keep track on chain via just looking up the account, how many votes a specific candidate has. And in the poll, we're going to have a different amount of data stored in it. So we'll have like a poll name. This can be like the question or the name, or yeah, this could be, let's call it poll question. That'll work better. Or we'll just call it poll. That'll work. So we have the poll, like what are the question, what's the answer, or the question that they're asking in the poll, like do you vote for, in our case, crunchy or smooth peanut butter? We'll have a description that kind of tells you a little bit more information about the poll so you can better vote what candidate you want. We're going to have a poll start time. So let's do poll start. And poll end time. And then we're going to do one last thing that helps us understand more information about the poll and also do lookups later on. Because one of the things that we're going to have to do is we're going to have to do lookups on how many candidates there are within the poll. So we might have 5 candidates, we might have 2 candidates. In our case, we'll only have 2. But say we have hundreds or something, we want to make sure that we understand how to do the lookups correctly and very quickly. We'll call it candidate index, or candidate amount. We'll call it candidate amount. All right, so we have our 2 accounts. And if you remember, as part of the PDAs, or program-derived addresses that you used in the previous project, we want to figure out how to find these accounts and do lookups on them very easily. So we're going to have to derive these things differently so that's very easy for us to do those lookups. So let's get into that. The way that we derive PDAs is we provide seeds. So in this case, for the poll, we will have a poll ID. This is so that we can get the poll and figure out which ID this poll is. So this is like, if you have a list of different polls that you are doing lookups on, this helps you understand which poll ID represents whatever poll that you're pulling from. So there's 2 ways that we'll have to do this later on in the actual application. You can either do just a incremental ID where it's just like 1, 2, 3, 4, 5, etc. Or you can do UUID as the poll ID. I think we'll just do 1, 2, 3, whatever. And the way that we'll have to do lookups later on is we can either cache it server-side on the amount of IDs and what are the polls and descriptions, and then just do verify on chain, Or we can just do like incremental lookups and figure out, okay, what are the first 10 polls? Showcase them on the website. There's a lot of different things you can do with this. We'll do a lot of that later on in the bootcamp when we productionize this application. But for now, we're just going to have poll ID. It's going to be a number, and that's it. And that's how we're going to derive the poll. So this is the seeds for the poll account. The other one is we're going to have candidates. And what I would like to do for this one is for the seeds, we would always want to make sure that it's identifiable based off the poll ID. So that whatever poll that we are pulling from with all the information, it's uniquely tied to that poll. This poll ID directly ties it to that poll. So we'll do poll ID, and then just so that we can do lookups based off of which candidate, we'll do the candidate name as well. So this ends up being our two seeds that we use to derive each candidate. So we have the seeds of poll ID and seeds of poll ID plus candidate name. The whole reason, and you have to make sure that you give these different accounts a lot of thought, but the whole reason why we're doing this is so that we don't have to redo our accounts later and redo the way that we do lookups later, because it's very important that we have good lookups at the beginning of building out our program or our smart contract so that we don't have any issues long term. All right, so here we go. We have our poll ID and our candidate name. And we have to also build out what are the instructions? What are the functions we're going to call within the smart contract? So let's go outline those out. So the first one that we'll need is, let's pull this over here. I'm going to move some things around so it's easier for us to view everything. The first thing that we'll need is we'll need an instruction. So we'll call these instructions. We'll need the instruction for initializing the poll. All right, so this will build the poll, take out all the parameters in order to build that poll, as well as the poll ID, and it will have everything we need to build that poll. So the next one that we need is we're going to have to initialize individually candidates on this poll. So this is initialize candidate. All right, so we have the poll, we have each candidate. The last thing, and the most important thing, is you can't have a voting application without the ability to vote for application. So we have everything we need. We have the instructions, we have each account. Now we can actually just start building. So let's go over to our local environment. You can open your favorite IDE, and you can just start building there. So I'm going to open Visual Studio Code, and I'm going to go open the specific folder that I created earlier with my voting D app. Okay, so I have the whole code base open now that we created earlier via the create Solana D app. We can see, just as a quick walkthrough of this actual scaffold, we can see here we have a web. This has just a basic Next.js app. If you're familiar with it, or if you're unfamiliar with it, that's okay. We will show you what's practical to get started. You don't have to go end to end. Basically, it just has a bunch of components, and within these components, you'll be able to see, so it was originally a counter page. This is the page for that. And then we have a bunch of information in order to get the counter. We have a data access. We have a feature which helps us actually showcase what that counter create is. And then we have that UI for the page. Don't worry about it if you don't know this too much. We'll just go through what's practically needed to build out the website. If you want to learn how to build websites or build the UI or the front end for any of these applications we build throughout this bootcamp, there's plenty of resources online that you can use. We're more focused on building the Solana side of things rather than the UI throughout this bootcamp. So we'll teach what's practical throughout this. All right, so this is everything that's in the web folder. And then what we're going to focus here is we're going to focus on the anchor folder here. So if we go here to programs, source, lib, we'll see that there's a counter program already based in here. We want to update that to our voting D app. So we're going to update this to voting. I'm going to just remove all of these instructions and then the rest of the accounts. So you end up having this very small file. There's barely anything in this file. I'm going to do a couple other things where we're going to change. We're going to change this one to say voting as well, this file. I believe in here it also says voting. Basically, you can change everywhere that says counter to voting. If you use this in the future, it should be automatic. And then right now, it's not. So One thing to note is that we need to also double check our anchor laying is the one that we expect. Throughout this whole bootcamp, we're using 0.30.1. I don't know in the future what the new versions of Anchor might hold. So if you're ever in the future using this, say, I don't know, months in the future, and we're going through this bootcamp,